Hey guys, I'm doing a video on glycogen breakdown. So let's go ahead and get started. So I have this giant molecule called glycogen. Alright, just a bunch of glucose units. So CH2OH on each one of them. Alright, you guys get it, so on and so forth. And these are connected through alpha 1,4 linkages. But sometimes one in every 10 glucose units generally has like a branch extending out, and this is called an alpha 1,6 linkage. There we go. All right, this is going to be important in a minute, actually. So, all right. So, glycogen phosphorylase, we're going to nickname it GP, is actually the main enzyme in this. This is what does the breaking down. It's going to do something called phosphorylasis, which is basically the same thing as hydrolysis, but with phosphate. So instead of using H2O to break down these bonds right here, it's going to use a phosphate group, and it will attach a phosphate group to this glucose unit, and with that we'll get a glucose 1-phosphate. The neat thing about this is that it doesn't require any ATP. It's not a kinase, it's a phosphorylase reaction. So it's really energy efficient, and it's really favorable for a cell to go under. It's going to attack from this end right here, called the non-reducing end. Um, and this right here we'll call the reducing end. Right here. Alright, so glycogen phosphorylase attaches a phosphate to carbon 1. So now we have this G1P for short, glucose 1-phosphate, or glucose 1-phosphate. It's going to turn into glucose 6-phosphate through this enzyme called phosphofructokinase, PFK. I'm sorry, phosphoglucose mutase. Let me erase that. All right, second. So something PGM. Okay. It's going to put this one carbon into a 6. It's going to move this phosphate group from a 1 position to 6 position. And now we will have another glucose. It'll be a G6 phosphate, and this can undergo many things. It can undergo glycolysis in the muscle, or it can go straight to the liver, and it'll end up being a free glucose. Free glucose. In the muscle, it undergo a glycolysis, and you can get a ATP and NAD from it, which is very useful. Uh, Over here, it would undergo hydrolysis instead of glycolysis. All right, and we'll transport it directly into sugar for tissues. So now, what would happen if we, with these points right here, the alpha 1,6, if we go all the way down, we're going to hit this point eventually, right? This is when this other enzyme called the debranching enzyme, GDE, glucose debranching enzyme. And what this is going to do is it's going to transfer 3 of the last 4 glucose units from the branch. So it'd be like, let's say like these, 1, 2, 2, let's say this is number 3 right here. These are the last 3. It's going to transfer these, and it's going to move them to the non-reducing end. It's just going to add on. This is done through a transferase. Then if we're like for this last one right here, this last one, we're going to have another enzyme called hydrolase, and this is going to hydrolyze the last glucose off. Right here, it's going to hydrolyze it. It's going to break this alpha 1,6 linkage, and You're going to get straight glucose, not G1P. Straight to glucose. And this is glycogen breakdown in a nutshell. Thank you for watching.